Well, good morning, good afternoon, good evening, wherever you are in the world today. It is now 10 a.m. Eastern, so we will begin the webinar. And today's subject is, do you follow good site safety practices? So this is an intriguing one because, unfortunately, recent accidents have again highlighted the fact that mechanical integrity and good maintenance capability has come into question. So we're going to explore that a little bit today, and I'll share some ideas and concepts with you. But just before we do that, I know some of you have been on previous exida webinars, but some of you might not. So first and foremost, let me just introduce a little bit about exida. Next year, March, is actually going to be the formal 20th anniversary of the start of the company. And originally, it was started by two leading lights in safety, Rainer Fuller and Bill Goebel. And since then, the company has developed and grown exponentially. Originally, it was to help manufacturers understand and get to grips with the new safety standard that had just come out then, which was IEC 61508. And since then, we've developed not just the capability of doing certification for 1508, but now we do certification for IEC 62443 on the cybersecurity side for products. And we also do personnel certification. Some of you may already be CFSEs or CFSPs. And together with that, we've developed the core capabilities of providing full lifecycle services for functional safety, alarm management, and cybersecurity, because all three have very similar life cycles. They have an analysis phase, they have a design and implementation phase, and they have an operation and maintenance phase. And to complement that, we also have a comprehensive suite of tools, software tools. Most of you might be aware of Excellencia and have used Excellencia, but the Excellencia suite now covers not just safety and alarm, but also cybersecurity. We have a cybersecurity PHA tool and an SL determination tool as part of the suite now. We are global. We've established ourselves all around the world. The most recent one has been in Israel that we established, and before that was Mumbai in India. And we cover most industries now: oil and gas, chemicals, petrochemicals, steel, automotive, pharmaceutical. So all of those are covered now: onshore, offshore, power distribution. And we measure our success through looking at our market share. Well, in fact, I mean, somebody once said that exida is the best kept secret because most people think TUV is the bigger organization and has done more certifications, but actually not. We've done far more than they have. And also, we've gone from just being owned by two people to being primarily employee-owned now. The original founders will eventually retire, but the company will continue to grow and prosper. We have more likely 120 global experts now. We've done over 1,000 certification assessment projects, and with Excellencia, we've modeled well over 500,000 CIFs. We also publish a lot of reference materials. Now, again, some of you will be aware of the webinars, of course, because you're attending, and these are all recorded and held on the website under the resources. We also publish a number of white papers. We have blogs, we have books. We've published more books on functional safety, alarm, and cybersecurity. And of course, we have our Safe Equipment Reliability Handbook, which is all the failure rates for practically any device you would come across in process applications. This, of course, is also inbuilt into the Excellencia tool, which makes it somewhat unique in that it's the only one that has this built-in database. A little bit about me: I've been around for a few decades. I've been in industry for more than 42 years. Started off as an engineer, design engineer, software hardware design engineer, designing control systems and then eventually designing fire and gas and ESD systems. I then spent a considerable amount of time in the UK with ICS and then with an American firm called Mezzo Automation doing DCS, distributed control systems for power applications. And about 8 years ago, I came back into safety again with exida. I'm also one of the primary trainers on the functional safety side. I also do the cybersecurity side, and I'm responsible for our end user services side. Now, with that being said, let's get into the meat of the presentation. So the question is, do you follow good site safety practices? And this is a question that I often ask when I'm teaching the class with end users because most end users, certainly managers, if you ask the managers, they all say, yes, of course we do. But if you ask the actual maintenance people or the operations people, they have somewhat different view. And again, what do we mean by good site safety practices? Well, in this case, it's how well do we carry out the work of maintaining mechanical integrity and also repairs. And here again, if you've ever looked at the Chemical Safety Board accident analysis, the videos they have, and they're very good videos and the animations, you would see that in most cases there have been lapses or severe lapses in the approach to doing mechanical integrity and maintenance. And in some cases, it's just a case of just ticking the box and just making sure, okay, yeah, we've looked at that, that's good, let's move on, without actually implementing proper repairs. So it's more or less just putting a Band-Aid on something and not really following through to make sure it's done properly and it's been properly reassessed. This, of course, comes down to two fundamental things. Firstly, culture. If the culture of the company is not conducive to promoting and supporting functional safety and functional safety management, then maintaining functional safety throughout the operations and maintenance cycle is going to be very difficult. The other aspect of that is making sure that people are properly trained and that the procedures in place are practical in terms of that they can be followed. And of course, they are being followed. In the case of several of the accidents, it was proven, certainly in the Texas City one, it was proven that they violated the startup procedures. There was another incident at a Tesoro plant where heat exchangers blew up, and that's because, again, they violated their startup procedure. So procedures are extremely important and they should be followed, because this last bullet applies to what we call the 3 Ps, which are all systematic. Systematic errors are insidious. They can only be removed or avoided by one of the 3 Ps, which is making sure that the personnel involved are competent and trained to do the work, making sure that the procedures in place are being followed, and that we have a paper trail. The 3rd P is the paper trail, to make sure that we can prove we're doing what we say we're doing and we're doing it correctly. So this is all part of maintaining good site safety practices. And do you actually know how good your practices are? Because again, most companies don't really measure it. And as you can see from this picture, this is a pretty unique situation. Well, not unique actually. It's a situation that can occur. Is he following safe practices? Absolutely not. So again, as I've said, if you ask many company managers, they believe that they do follow good site safety practices. But again, that's a view. They don't necessarily have the metrics in place to be able to measure it and to be able to show that they're doing it correctly. So there is a simple method that we can use, and that is using a site safety index model, which is basically a sort of semi-qualitative way of assessing what the capability is. And I see already there are some questions popping up. I'll address them at the end. I'll just keep going, and then we'll have some time at the end. And what that does is it gives you an indication of where you sit relative to, you know, good, bad, non-existent, near perfect, and perfect. Very few sites can actually claim that they do perfect maintenance, which means that they fix everything in a timely fashion. They make sure that they retest everything properly, that their mechanical integrity is done correctly, and that their maintenance is done properly, and everybody's trained. Another way of doing it to find out is through an independent third party. So again, the use of independent third parties is good because it provides a completely unbiased view. And again, if it's done properly, there's a combination of interviews and an assessment. And that way you can get an accurate measure of where you are. And being able to measure what we call SSI is very fundamental and key in understanding where a company currently sits, and if it needs to make improvements, where these improvements can be made. And we do actually have a website that you can visit, which is called the Site Safety Index website. And that has, I think, a list of about 40 questions that you can go through. And again, it's semi-qualitative. So you'll get a feel for where you sit. And it's a first pass. So why is the SSI important? As I mentioned earlier, when the Chemical Safety Board has looked into some of these accidents, what they've found is that oftentimes there is a combination of things, such as there's a poor site safety culture. Management isn't really committed to doing things correctly. They're more interested in efficient operation and keeping the cost down as far as possible. The other thing is the practices and attitudes. These have been also an area where things have not gone well, and again, that can be linked back to culture. If the culture is one of punitive in terms of we don't want to hear that there are problems, you just get on and do what you need to do, we just got to keep making money and keep our costs down. And when you look at these investigations that have been done, you can see Texas City is an example of that, even the Macondo, and then the Geismar explosion in 2013 and the DuPont Bell phosgene release in 2013. Those were traced back to port site safety practices. So what is this SSI model? Fundamentally, it's a simple qualitative model that's using concepts from 1508. And there are 5 levels. We talk about SSI 0, where this is virtually nothing gets done properly. You know, repairs are not always done. This is where the culture is not good. Manpower may be low. They've got too much to do. Yes, they know there's a problem. We'll leave it in bypass. We'll get to it whenever we can get to it. So that's the sort of thing. The testing isn't done. There's normally a run to fail policy where equipment isn't replaced until it fails. And we know that when it comes to safety instrumented systems, that's a no-no. You have to make sure you follow the useful life of the devices in each of the CIFs and make sure that those are either replaced or refurbished when they get to the end of their useful life. So that means you have to have a good tracking system and you have to follow good maintenance and mechanical integrity. So from 0, you go up to 4, which of course means you're doing everything correctly, you're using data correctly, you've got everybody trained, and this is the highest possible level you can get. Now, in our Excellencia tool, we do have the SSI is included in the tool. It's part of the Markov modeling. And we normally assume good. So it defaults to SSI 2, where repairs are usually correctly performed. Testing is done correctly and mostly on schedule. Most of the equipment is replaced before the end of the useful life, and it's selected according to specified environmental limits and process compatible materials. And this is another issue where sometimes valves are used or valves have been purchased and they haven't really thought about the environment, and especially if it's in severe service, and if the valve material is not suited to that, then the valves will very quickly degrade and you'll have problems. So that's typically where we assume most are. So again, this is based upon a simple questionnaire that any end user can use themselves to give themselves an indication. If you want more accurate, then it's a combination of a questionnaire with audits and interviews. And as I've said, when I talk to most companies, they tend to think they're in either the 2, the 3, or the 4 category. None of them seem to think that they're down here at 0 or 1. So what are the important factors that can impact our site safety index? And again, part of it is equipment selection and qualification. If the equipment hasn't been selected correctly for the environmental or the operational conditions, then you might argue that, well, why would you not select the right equipment? Well, sometimes that happens, that the engineering company isn't fully aware of the end operating environment, and if it's not in the specification, then again, this can be a problem, because what that means is that we'll probably have more breakdowns, more failures, and it'll require more attention. How well the testing was done during commissioning. So here again, if there wasn't proper and thorough testing, we may end up with problems turning up later on during operation. The safety validation test, if that wasn't done properly, and again here, if we have a safety instrumented system and we are following 1511, we should have done an FSA 3 before we start up. And I have had discussions with end users who have not done FSA 3s. They've done a PSSR, but they haven't done a proper validation. Proof test procedures. Here again, if the proof test procedures are not clearly written and easy to follow, then most of the time they're not going to be followed. And as when I teach the class on the FSC 100, I usually say, if there are designers present, because sometimes engineering companies attend the classes too, is don't design in isolation. You can come up with a proof test procedure, but if it takes 6 or 7 hours to do and it's 45 pages long, guess what? It's not going to get done. So you need to talk to the operators to find out what their sore thumbs are when it comes to doing proof tests and how they conduct maintenance. Proof test documentation as well. We should, when we do a proof test, we should be recording the as found and as left conditions. Here again, if that isn't done properly, then we could end up with problems being introduced by the fact that we did the proof test. Failure diagnostics and repair procedures. Here again, if those aren't correct, if we're not properly repairing in the time given in the SRS. Now remember, with the safety requirement specification and as part of the SIL verification calculation that's done for the PFD average or the PFH, we look at these mean time to restore. How long does it take us from finding a problem, whether it's from the diagnostics or from a proof test, to repairing that problem and restoring the SIF to normal operation? So again, if we're not doing that properly, if we're not following that, if we're missing our proof test intervals by more than 10%, and we do that on a consistent basis, if we're doing annual proof tests and each time we miss it by 10%, then by the time we've got to the 3rd year, we're in serious trouble, because as soon as we exceed 10% on the proof test interval, we start to degrade the performance of the SIF in terms of its SIL. So the amount of risk reduction it's providing, or the amount of mitigation it's providing, is seriously eroded by the fact that we are not testing correctly. Device useful life tracking and replacement. As I mentioned earlier, if we're not replacing devices before the end of the useful life or by the end of the useful life, either replacing or refurbishing, then once we get outside of useful life, all bets are off. And useful life is basically the flat portion of the bathtub curve where we can approximate to a constant failure rate. And everything we do in terms of the probability calculations, the probabilistic calculations, all predicated on the concept of a constant failure rate during useful life. Once you get outside of useful life, it's no longer constant, so it's unpredictable. So you really don't have a PFD, and you won't have a SIL. So even though you may not have had a problem, your likelihood of having a problem, it starts to go up almost exponentially. For modification as well, if we don't have proper modification procedures in place, then we can introduce systematic issues, and this will impact, again, our overall performance. The same for decommissioning. If we have to decommission a SIS, what happens then? And a bunch of other things also come into play. So if we look at the operation and maintenance phase of the life cycle, you'll see here that this is this one box. And again, if you think back to the old 20-20-20 adage, which used to be 20 weeks for design, 20 months for implementation, and 20 years of operation, we're going to be spending over the lifetime of the SIS probably more than 95% of our time here in the operation and maintenance. And all of this is covered under clause 16 in the standard. So here again, we could do our analysis right, we could design our system correctly, we could have our SIFs all nicely designed to meet the right SILs and everything else. And once we get into operation and maintenance, if we don't do the maintenance according to the SRS requirements in terms of the proof test intervals, the mean time to restore, tracking useful life, making sure we effect proper maintenance, we keep records, all of that will very quickly deteriorate. And this is one of the reasons why in the 2016 edition of 1511 they introduced the requirement for a stage 4 FSA. In the stage 4 FSA, I just did a webinar yesterday on, why do we bother with FSAs? But the stage 4 FSA requirement is to be able to look at our performance. Remembering, of course, that the 1511 standard is a performance-based standard. So the difference between a performance-based standard and one of the old standards that were prescriptive is that a prescriptive standard says this is what you have to do and this is how you do it. There's no leeway, there's no flexibility in that at all. A performance-based standard, on the other hand, says this is what you have to do, but how you do it's up to you, as long as you measure your performance. And this is an area that was not being done properly, and which is why the committee recognized that, and now you have to do a stage 4. Here again, the wording says periodic. It doesn't define what that period is. And you could use the 5-year window between doing PHA revalidation, because during that 5 years, provided you haven't had any major incidents or problems, you should have been doing some proof testing, you should have maintenance records, you should have good data that you've been gathering if you've had any failures. So all of that information can then be used in the PHA revalidation, especially when it comes to initiating event frequencies, to see, okay, did we get it right the first time or did we not? And we can modify accordingly. So again, if we don't have the proper performance indicators available, we won't be able to measure performance. And then again, if we're not doing or following good site safety practices, then we are going to have problems, and we won't achieve the performance that was originally intended from the original design. As I said, we're performance-based, so therefore we do need to measure. We need to know how well our SIS and its SIFs are doing in terms of the risk reduction. Is it still performing the way we need it to perform? And that means we have to have the appropriate metrics in place to do this. You can, of course, use leading and lagging indicators. There's another webinar completely dedicated to leading and lagging indicators, plus there's a paper on the website on leading and lagging indicators. But ostensibly, lagging indicators are things that have happened in the past that we can learn from, whether they're incidents, real or otherwise, near misses, maintenance issues and problems, failures, All of those things are historical, and we can use that because if we've been getting a lot of these problems, we should be able to reduce them. The leading ones are to give us an indication of the likelihood of having a problem in the future. And of course, if we're not, for example, if we're not doing the inspections correctly, if we're not doing our proof testing on time, if we're not training our people, if we're not doing the assessments that we need to be doing, then the likelihood of having a future event is now beginning to increase. So this is why it's important to be able to measure the performance. And this comes back to what I was saying about the site safety capability and it hinging on the two things being culture. And again, if the culture is not there, it is very difficult to be able to go to management and say, look, I have to replace these devices because they're coming to the end of their useful life. And if the manager says, well, why? Have they failed? And you say no, then of course the pushback is going to be, well, why do I need to change them if they haven't failed? Why should I spend that money? So this is another problem, and that plays into the ability of maintenance people to be able to follow good site practices. So therefore the management team has to buy in and support the overall process safety approach. This also means that we have an open and learning culture because, again, if we're using our lagging indicators and we've had problems in the past, we should learn from that and be able to modify accordingly, whether that's some further training that needs to be done or whether it's a revision of procedures or the addition of new procedures, whatever it takes to do it. So doing things right and doing the right things should be the mantra. And what do we mean by that? Well, we make sure that our O&M personnel are properly trained and that they are following the procedures. If the procedure is not correct and you find that they're not following procedures because they believe the procedure to be cumbersome or it's not written correctly, then that needs to be looked at and that needs to be changed because that will be a potential systematic issue. If we have the right metrics in place and we're following our procedures, then we should be able to accurately measure our performance. And again, if it's done right, it will actually save time and money. Here again, what you find is that companies that are at the lower end of the SSI spectrum experience more outages, more downtime, because they have a lot more spurious trips or they have equipment failures. So that costs money, plus every time you have to start up, that is a potential high risk situation. So what are the specifics? As I mentioned already, we have to carry out an FSA 4, and it uses the word periodically. And you can set the time. End users can set the time. Whether you decide to do an FSA once every 5 years, whether you decide to do it once every 2 years. I've had situations where companies will look at, okay, if we've got SIL 3, we need to be looking at that probably more frequently. But again, it's really down to the overall performance. If we're not getting a lot of incidents and problems, then the 5-year window may work. If we're getting trips and problems, then maybe we want to be looking at it much more frequently than 5 years. So again, the point is that the end users can set that themselves. However, they need to do it. It needs to be done. So we should be doing that. And I have actually been doing some FSA 4s for some clients. I mean, it's been 3 years since this came out with the 2016, and still companies are not doing it. So what needs to be measured? Again, when we did the design, we identified key parameters. So of course, proof test intervals. Everybody hears about proof test and proof test intervals and what is a proof test and what isn't a proof test. Let's not confuse a proof test with a functional test. And a proof test should be designed to find potentially dangerous faults that any automatic diagnostics can't find. And this is where, when I teach the class, the euphemism I use is RTFM, read the flaming manual, because the safety manual will give you suggested proof tests. If you're using Excellentia, then you can do that automatically with the tool. But if you're not, then you need to be looking at what the manufacturer's recommending for the particular device, and then create a proof test for the overall SIF that will meet a certain level of coverage in terms of the ability to find potentially dangerous faults. So it's not a functional test, it's an entirely different test. It may encompass part of the testing we would do as a functional test, but it's not there to prove that the SIF works. It's there to find potentially dangerous failures. So it's important that we follow the timing. And here again, I had one client that came to us because the engineering company, in order to meet the target SIL, had come up with a 3-month proof test interval without consulting the end user. And the end user was telling me, well, there's no way with the number of SIFs we have and number of people we have that we can do 3-month proof tests. So we're already set up to fail. So again, that has to be looked at pragmatically. I mentioned the reason why we have to make sure it's done in a timely fashion. So again, if we've set the interval at 18 months in our calculation for our SIL and we miss it by a couple of weeks, okay, no biggie. I mean, we should look at trying to get it as close as possible. But if we miss it by 3 months, now we're going to have a potential issue. Because part of the performance measurement should be looking at how frequently are we able to do the proof testing on time, and if we're not, by how much are we missing it? And it shouldn't exceed 10%. Also, the effectiveness of the proof testing, is it as effective as it was originally intended? From the O&M side, for the personnel assessments, are we doing our regular assessments? Now here again, in 2016 edition, it requires regular, again, uses that term, assessment. So you may decide, the end users may decide, we're going to do that once a year. If we're not having problems, then you might be able to stretch that out. If you are having problems or you've got staff turnover, then you may have to do it more frequently. So the point is, it needs to be done and it needs to be documented. So what do we need to record? Well, we need to look at demands on the SIS, whether they're actual, real or false, and then any incidents or near misses. So if a relief valve goes off, that's obviously something that's not right. It's an indication of all is not well. And then we need to look at that and find the root cause of that. We obviously need to record both random and systematic failures. This is an area that gets confused very often because most of the time people think that failures in the field are all systematic. Not necessarily. And in fact, when we do our probabilistic analysis and calculations, we base that on random failures. So the adage that I suggest to most of the training classes I've done is that the assumption should be random until proven otherwise, because then you log it as a random issue, and then later on, if it turns out to be a systematic issue, that's different. So for example, if we have, say, manufacturer A has a pressure transmitter and it fails in one of the SIFs, and we replace and restore, and then 3 months later the same manufacturer's device but in a different SIF fails. So again, these would be random, but now there may be a potential systematic as to why is this particular manufacturer's device failing? Is it because we're not using it correctly, it's not been set up correctly, or is it not really suitable for the application? So these things would have to be looked at, and that's part of getting down to the root cause of it. Proof testing, recording the results of proof testing, including the as found. Now again, a proof test should include a visual inspection. So there have been several accidents where recently it's been proven that there was no visual inspection done of piping, and the piping was wafer thin and gave way under pressure. So the purpose of the visual inspection is, number one, to look for potential signs of corrosion, loose connections, unauthorized modifications, plugged impulse lines, Those sorts of things, that's what we're looking for. And then from the repair and restore times, we're looking to see if they're within the requirements specified in the SRS, and if they're not, then again, we need to look at why is that, and do we need to change our operational procedures and how we're doing the maintenance, or is it actually that we need to go back and adjust the SRS, in which case we would have to do a safety justification and a revalidation of the SIL. Maximum permitted repair times. This is something that was included in the 2016. So in other words, if you leave something in bypass to repair it, you have to specify what the maximum time is to leave it in bypass. And how often we've exceeded that time. We should be looking at that, because again, if we're exceeding it, why are we exceeding it? Is it because of our site practices? In other words, we're not keeping spares on site and it takes us longer to order parts? And are the procedures being followed? If they're not being followed properly, then that's another issue that we need to be able to track, and we need to be able to analyze, and then we need to be able to correct. So this comes down to, again, our site practices. As I mentioned to you earlier, the point being is, with this performance measurement, if we've got the right approach in terms of culture and practices, we should be gathering good quality data that we can then reuse, or we can use when we revalidate our PHAs. And like I said, if you're OSHA PSM site, you have to revalidate every 5 years. We can also, at that point, assess whether the proof test intervals are still valid or not, or can be extended. If our performance is better than we actually originally anticipated, then we can look at potentially extending out the proof test intervals. So again, if the whole point of following this process and this approach is that we balance out. So if we can improve, if the performance is improving and better than we originally thought, then we can extend out our proof test intervals, which will save us a bit on maintenance costs. It'll also enable us to confirm any assumptions that we've made on the demand rates and the hazard frequencies. How often are things occurring, and are they within what we originally thought? So this is another reason. And this again comes down to, if we're following good site practices, we're doing maintenance and mechanical integrity diligently, we're recording everything, then we should be able to have good data that we can use. Because what we want to do is compare our performance, the actual performance, with the assumed performance when we did the original design. So is our risk reduction adequate? If it is, fine, we can continue collecting. If it's not, then we can go back to the analysis phase and look at maybe a redesign or some form of change. If the risk reduction is more than adequate, if there's a potential over-design that we've overestimated the hazard frequencies, then again, that allows us to modify our design. But the point is that all the data that's collected and the lessons learned during plant operation can be used for analysis and for future performance. So that then brings us to summarize where we are. So if we have the right approach in terms of culture, in other words, a safety-first culture, where we have properly trained and competent O&M personnel with good or better site safety index capability, in other words, we're getting towards SSI 3 and SSI 4, that's where we want to be. We should be making sure we monitor this, and we can do that as part of an audit. So when we do our performance reviews, we can also look at how well are we doing from the site safety point of view, site safety index point of view. This means that we need to have the proper operating and maintenance procedures in place, and that they're obviously being followed. I'm a great believer in checklists, those people that have been on the course have heard me say this so many times, but if I always refer to the pilot analogy, that commercial pilots, doesn't matter if they've been flying umpteen thousand hours, every time they get in the cockpit, they don't rely on their memory. They get out their safety checklist, their pre-startup checklist, and they go through it and make sure that it's correct. And therefore, if we develop a safety checklist, then we can ensure, number one, consistency, and number two, we don't miss anything. We can also look at developing and maintaining some leading and lagging style indicators. That's very helpful and useful. We should be doing the regular employee competency assessments, and again, that would be recorded as part of performance. And making sure that proof testing is conducted in line with the SRS. So as I said, if the culture's not right, if we don't have the right approach to site safety, and we don't do our proof testing on time, and especially if we exceed the proof test interval by more than 10%, then we're going to start running into problems later on. So we need to make sure that that's done in line with the SRS. We record all these activities accurately and faithfully. The use of tools can obviously assist in recording and auditing, as long as the tools are appropriate to be used. And they can also help us with analyzing failures, false trips, and our actual SIS performance. And those of you using the Excellencia tool, if you've looked at SILSTAT, that's another extension of Excellencia that can help with this. But there are different ways of doing it. Okay, so that's the end of the webinar. And let's see what sort of questions that we have. One of the questions is, can we develop the digital twin based on design data for a newly commissioned plant and later update it based on data received from it? Yes, you could. You could certainly do that. But it's not something that people do. I mean, it does help you with looking at performance. And the other question is, can you give an example of leading and lagging indicators, which I already did. But by all means, go to the exida.com website and look up the leading and lagging indicator webinar that's there, and also the paper that's there. That should explain in more detail. But I've given some ideas of lagging indicators. You know, what sort of trips that we had, whether they real or false, demands on the SIS and its CIFs, and then looking at failures, and also looking at near misses and any procedural violations as well. Those would be recorded, and so those are potential lagging indicators. The leading ones, as I said, was how often are we doing the reviews of the personnel. Also, are we doing proof testing on time? Are we following through on mechanical integrity? Are we tracking useful life and either replacing or refurbishing? All of those types of things. Any other questions? Is the SSI questionnaire on the Exeter website? It's actually on www.sitesafetyindex.com. If you go to that, that's where it is. Any other questions? Okay, well, I thank you for your attendance, and again, as you can see below, if you have any further questions, by all means forward them on. You can forward them on to me directly if you like. My email address is sgandy, that's Gandy, at exida.com. I'm always happy to answer questions following the webinars, because I know sometimes people, they attend the webinars and then later on they think, oh, I wish I'd asked this question. So if that happens, just drop me a line. So with that, I wish you the good rest of your day wherever you are, and thank you, and look forward to you attending a webinar in the future. Thanks very much. Oh, no, another question. Is there a list of abbreviations? Yes, there are lists of abbreviations. You can find those from the website too. If there are specific ones you want to know, again, drop me an email. I'm happy to let you know. Okay. With that, I bid you farewell. Thanks very much.